Now we turn our attention to proofs of parallelograms. I'm still going to ask if the proof triangle is congruent. Still going to ask for CP-CTC proofs, but now you're going to have parallelograms in there. So this is why I'm going to say it's getting tough. Are the proofs actually that tough? No. Here's what's tough. Now you got all those parallelogram properties on top of what? 5 previous units worth of theorems, which they're all good to go. You can use any of them. Now just adding more stuff to the pile that you can put into the statements and reasons. So I'm going to try to start you guys off with a basic one here. All right, a basic one. I'm telling you, both of these quadrilaterals are parallelograms. I'm going to somehow get you to prove to me that WX and ZY are congruent somehow. Before we start, I want to do this every day. Let me list off the 5 different properties of a parallelogram. If I don't know these, I'm not doing the proof. So if you got to look back, you look back. This isn't a quiz here. 14, first property. Opposite sides parallel. Next property, parallelograms. 6. Do I have somebody not here today?
No, I'm here.
Okay.
Opposite sides congruent.
Opposite sides congruent. Next property, 10.
The diagonals bisect each other.
And I'll make it this easy on everybody. If the diagram doesn't have diagonals, you're not going to use that property. All right, some of these diagrams that we're going to do in the proofs, the parallelograms don't even contain a diagonal. So don't even worry about it. 4th one, 18. Consecutive angles supplementary. And another fact, very rarely am I going to use that property here. Very rarely. Usually in algebra, I'll use those instead, but not for proofs. And then the last one I'm looking for, 20. Opposite angles congruent. Most proofs, not all, most proofs will be these 3 right here. Parallel, congruent, opposite angles congruent. All right, so now that we reviewed those 5 properties, how can I get WX and ZY? I got to use, it's a parallel, I'm telling you it's a parallelogram to tell you, use the darn properties. Don't try to do this your own way. Use properties to get WX and ZY. First of all, what are WX and ZY? Are they angles? No! What are they? Sides. So I think I'm probably going to use opposite sides or congruent. All right, why am I even looking at any of the other ones? It doesn't have diagonals, and all the other ones deal with angles. Right? And the last one deals with parallel sides. I'm talking congruent sides. So probably right now, I'm going to have to show sides are congruent. Talk it over in your group. Just don't stand. Oh, also, just don't stand alone in your group today, because I'm calling out a number, and that's not my bad if you didn't hear what your group was discussing, or you didn't contribute to your group. That's not my bad today.
No, you have to say
Can't you just say like they're congruent and then you can just substitute? Can't you do that? Why do you replace it?
One true fact that you got because it's a parallelogram. One true fact. 23. What's true up here? WX is congruent to VT. Perfect. I tried to break you guys in yesterday with the reason. Parallelogram, or if you want to use the symbol from your textbook, go ahead. Parallelogram implies, tell me the property. What property was just used here? 24, what property was just used? Parallelogram implies opposite sides, congruent. Perfect. So I have WX, which is in my proof statement, congruent to VT. At least I have something written down that's in my proof statement. Well, where does ZY come in now? Where does ZY come into this? 8, anything about ZY you know is true. Okay, I'm just going to stick that right into statement 2. There's no reason for me to rewrite reason number 2 again. All right, so I'm just going to stick that right in statement 2. That VT is congruent to WZ. This is why I think it's tough. Now you got to connect it using something from our previous 5 units, because the parallelogram properties aren't going to get you here. It's something we've already done multiple times. I know it's been a while because unit 5 we did indirect proofs, and it's been a while since we've done a regular proof traditionally. How do I connect WX and YZ if they're both equal to VT? Did we discuss that in our groups yet? 3? You use substitution. Yes, both of those WX, ZY, both equal to the same line segment, so they're equal to each other using substitution. Questions? Okay, I'm going to, if you don't have to use them if you don't want, I'm going to come around with colored pencils, because as we go to the next diagram, you will notice multiple quadrilaterals in the diagram, multiple four-sided figures. I want to make sure we all realize where the parallelogram is. Somebody in each group, please collect them at the end and put them in this white bin as you leave. Okay, let's get your givens down. And then we'll talk. Make sure you know where the parallelogram is. I had both my geometry classes today. A few students think and apply the properties to EDFB because it looked like a parallelogram. No, that's not the parallelogram in this diagram. Right here, ABCD. Here's where I can apply all the properties to. Right there. Nothing else. And it also tells me DF and EB are equal. Got it. So DF, EB are equal. All right, prove the triangles. This is old school. Prove the triangles. We don't have time to review the 5 methods, but you know there's 5. Another minute back into your group, and then we'll regroup. Back into your group using the properties of a parallelogram. Can you get a pair of sides or angles congruent in those 2 triangles using parallelogram properties? Go ahead. Just one. I just want one, and then we'll keep building.
Subtract AB, yeah. So next it's just going to be.
All right, give me a pair of sides or angles because it's a parallelogram. 10, pair of sides or angles. I need a pair of sides or angles because ABCD is a parallelogram.
A, B, and DC.
Okay, all right. I'll go. We're going to go this way first. All right, I got it. A, B, and DC. They're not at sides in my triangle, but hopefully you guys see where I'm going here to get sides in the triangle. So AB congruent to DC. Got it? Parallelogram implies. What property was just applied here? Parallelogram implies. Give me the property. 17.
Opposite sides.
Good. We're all good there. Where are we going from here? Where are we going from here now? I got DF congruent to EB in the givens, and then Jonah just gave me AB and DC. Where are we going with those two to get another side? 3? Okay, that's fine. You guys aren't, just going in, but that's fine. I'll just keep going. DA, I thought you guys were going to use AB and DC there. DA congruent to CB. Yep. And I'll just put it right in that statement because it's the same reason. And then does everyone realize that this is a pair of sides now in your triangles? That's a pair of sides. Okay, now I'm looking for how do I use AB congruent to DC in this proof to get another pair of something. How do I use AB congruent to DC? That's what I'm asking for right now. 23, how can I use AB congruent to DC? Everyone remember subtraction. It's not going anywhere. It's not. We just add more theorems. DF minus DC is equal to EB minus AB. Subtraction. And then we know the deal right after. Substitution. To say, let's see, side EA congruent to side CF. A lot of hash marks here, huh? And that gives me a second side. Second side. Now you're going to have to pull in all your brain power from your group. Because this third pair that we need is not very, can't see it right away. You're going to have to think here. And here's a hint. Still use parallelogram properties to get there. I'll give you a little more time to talk about it. Where's that third pair of something here? Let's go. Where's the third pair of something? Ooh, we're going to have to go. Big review theorem coming up. Big review theorem. Listen in your group. Listen one in your group. What's going on?
And then you just did and then we already know
so we know that DC and CF.
and we know that
Way to
it's our
go.
lines.
Or angle BCF and angle
What are they? Opposite?
No, they're
not opposite side.
Opposite angles.
Okay, keep talking to me. Keep talking. 23. What property am I going to have to use now? Good. To say which two angles? There you go. Some of you are like, oh, that's not even in. You're right. That's not in the triangle, but it's certainly going to help me get two angles in the triangle. So angle DAB congruent to angle DCB. Parallelogram implies opposite angles congruent. How do I get those in my triangles now? What's the connecting piece? How do I get those in my triangles? 24, how do I get those opposite angles into my triangle?
You say that angle DAB is perpendicular to angle.
What? What?
Sorry.
Yeah, I don't know where perpendicular came in there. Perpendicular.
Oh, sorry. Supplementary.
Thank you. Now, you're good, Mahmood. You've proven to me your worth. I heard a lot of people say the theorem we used to I gave you in Unit 2, which is supplements of congruent angles are congruent. Yes, that's what we're going to use, but you have to do what Mahmood's doing. Where are the supplementary angles? Until you cannot use that theorem until you tell me what angles are supplementary. So that is my step 6. Angle DAB, and if I go DAB, I got to go DAE are supplementary. Angle DCB and angle, let's see, DCB, FCB are supplementary. How do I know? How did Mahmood know they were supplementary? This isn't supplements of congruent angles. That's to say the angles are congruent, not supplementary. How do I know those angles are supplementary up there? What do we got? Old theorem, review theorem, 16? Darn right. Linear pairs are what? There you go. Linear pairs are supplementary, and then I can say the angles are congruent. Whew! 8 steps is the new norm. 8 steps, the new norm. Now I can say DAE congruent to angle FCB. Supplements of congruent angles are congruent. Yep. And then you got your triangles congruent. Got to put my A in there next to the angles. Triangle DAE congruent to triangle BCF. Last thing I need to know on this proof from somebody is what's your method? What's your method here of the 5? 15, what's your method? Thank you. How do we feel on that? Again, difficult? No. But it's just so much stuff we could put into a proof now. We have 6 units of theorems. 6. Oh, we're not done. Go ahead, set yourself up for this one. You guys have SE congruent to QF on this one, correct? That's what you're asked to prove on this one? Yeah. Okay, just making sure. Because different classes have different proofs. All right, look at the proof statement. I got to prove segment SE and segment QF are congruent. You guys know what I asked next. Those aren't going to be congruent until triangles are congruent. This is a CP-CTC proof. So where are the triangles I need then? Take a quick peek. What 2 triangles am I going to need congruent to get SE and QF? Name the triangles for me so I can highlight them up here. 18. Which 2 triangles contain SE and QF as full sides?
Did you say 18?
I did say 18.
Triangle SPE and RFQ.
Say that one more time.
Triangle SPE.
Okay, S, yep, got it.
And RFQ.
Got it. You got it. Got to prove those 2. Ready? 1 minute in your group. Find me a pair of angles or sides somehow. 1 pair of angles or sides. Find them, and I'll get back to somebody in a second. Find me a pair of angles or sides.
Yeah. Angles or sides.
And then you can also do the side for top.
Oh yeah, you can get these 2.
Oh, I know, I see.
All right, talk to me. Where are the angles or sides you want? 1 pair only. Number 9. 1 pair only. Okay, I'll take that. PS and QR. Parallelogram implies, what property are we using for that one? 24, what property for those two sides? You got it. All right, so there's a side down. 2 more to go. 2 more to go. If we took yours, go ahead. About another 30, 45 seconds to find another pair if we already took yours. What's coming up next now? What's going to come up next if I get called on? What's coming up next? Or is another pair of sides or angles? All right, what do you got for me? Number 10, another pair.
PQ congruent to SR.
All right, I got to ask where that's going before I write it down. Like, why do I need it?
I thought you had to prove the big triangle on top, like the entire thing. Like
That does why? Okay, I'll listen. I want to prove triangles that have SE and QF. Right?
Oh wait.
I don't know. I just don't know, Jonah, where you're going when you give me PQ and SR. That's my question. Right? Because they're not in the do you see the 2 triangles I'm asking you to prove congruent in this one?
Yeah.
The 2 on the one on the left and the one on the right.
Yeah.
Is that in the triangle?
No.
Is that in the triangle?
No.
So that's why I'm asking where you're going with it.
Yeah, I don't really know.
Okay. Is there any other angle or side you can tell me in the triangles I'm looking for?
You could do angle PES.
Yep.
To RFQ.
Yep, that's going to take 2 steps, though. Not right away, though. Yes, everybody, it's going to take 2 steps to say they're congruent. Step 1, saying they're right angles. PES and QFR, right angles. Perpendicular lines form right angles. And then you guys know the deal. And I go quick. I'm going quick now. This is stuff we've done already and a lot. It's not like we just did it one day. We've done this a ton, so that's why I'm going quick. PES congruent to QFR. Right angles are congruent. Okay, so there's an angle. All right, so we got one more pair. And I'm not going to let you go back in your group and talk because this is a little bit more difficult. This is a little something new and old. What do we know about PQSR? What type of figure is it? It's a parallelogram. And in that parallelogram, what do I call SQ? That's a diagonal, isn't it? So I want you guys to start getting in the mindset of, if I have a parallelogram with at least one diagonal form, I'm going to have these angles I've talked about in the past. If I have a parallelogram with a diagonal, these special types of angles are going to be formed that we have discussed in the past. Anybody know what I'm talking about as far as those angles? What are they called? Go ahead, guys. What are they called? Alternate interior. You will always have alternate interior angles in a parallelogram if a diagonal is drawn in. Where are those alternate interior angles? The ones we want anyway. PS, E, and RQF. You could go ahead and mark them, but I'm not saying they're congruent yet. Last question. When are alternate interior angles congruent? Not every time. Only when I have parallel lines. Do I have parallel lines in my proof yet? No, but do you know lines are parallel? Yes, because it's a parallelogram. Which lines, though, do I need? Because you have 2 sets of parallel lines here. Only one set gives me these alternate interior angles. Look how they're formed. Look how they're formed. You should recognize the parallel lines you need right away. What lines need to be parallel here? 18, which 2 lines? Ready, Claire? Here's that alternate interior angle. Here's that one. Are they on PQ and SR? Do those two angles, are they on PQ and SR? Everyone seeing that? They're not on PQ and SR, right, Claire? So I don't need those two. I need PS parallel to QR. And I know we're in honors and I probably shouldn't be saying this, but if you ever get confused or you're unsure, what should you probably do? Just write them both down. Right? Write both sets down. Why not? You're not going to be wrong. Right? Both of them are true. You know one of them's got to be right. So write them both down. Just be on the safe side. Write them both down. All right? Parallelogram implies opposite sides parallel. You need parallel lines before alternate interior angles are congruent. All right, now tell me the alternate interior angles are congruent. Angle PSE, congruent to, if I go PSE, what do I got to go? RQF. Ooh, anybody remember why? Review theorem. Why are those angles equal? Review theorem. What's up, Charlotte? Yeah, remember those? Parallel lines imply alternate interior angles congruent. And there is your final piece, right? There's an A. Triangles are now congruent. 8 steps, the new norm. Triangle, make sure I name these bad boys right. PSE, congruent to triangle PSE RQF. Got a method? Somebody got a method out there? Because I'm asking because I have 2 angles and a side. So it could be angle side angle or it could be angle angle side. Take a peek where that side is. 5, what's my method here?
Angle.
Darn right, side's not in between. And then finish your proof up with a little CPCTC. There you go. Woo! Parallelogram, diagonal, alternate interior angles. Every time. Parallelogram with a diagonal, alternate interior. Questions there from you guys? One more to go. And my job as your honors teacher is, all right, make sure you understand the basics while at the same time challenging you, which is this proof right here. Okay, we've got 2 basic proofs, moderate, average level proofs. Now it's time to get an honors level proof. Okay, everything is written in for you, right? I got a couple midpoints, and this whole thing is a parallelogram. How do I get the triangles on the outside congruent? How do I get these 2 congruent? All right, that's what it's asking me for. Quickly, in your group, find me a side or angles based on your properties. Give me a pair of sides or angles that should be equal, because this is a parallelogram. Give me a pair of angles or sides, because this is a parallelogram. That'll be congruent. All right, what do you got? What are your sides or angles that are congruent? 12 sides or angles. DA, congruent to CB. Perfect, I like it. Parallelogram implies opposite sides congruent. Nice, got a pair of sides, everybody. Got a pair of sides. If I took you and your group's side, find me another pair because it's a parallelogram. Go. Go. What's the other pair that's congruent because it's a parallelogram? Got another pair for me because it's a parallelogram. 10. Another pair?
Angle A is congruent to angle C.
Yes, yes, yes. Angle A congruent to angle C. Parallelogram implies. Ooh, we haven't used this one today. Actually, we have. Never mind. We used it in the first one. Opposite angles congruent. Put a little A in there. Ooh, is this really an honors level proof? Or am I just trying to hype it up too much? All right. Next up. What's in the givens we have not spoken about yet? The old midpoints. So watch. Here you go. So it says E is the midpoint of AB, which to us at this point would probably mean what? AE and EB are congruent. Is that going to help me though? No. One's in the triangle, one's not. That's not helping me. F is the midpoint of DC. Okay. So DF and FC are equal. Does that help me? No. One's in the triangle, one's not. That's not helping me. What do I need? I need FC and AE equal. I don't need these two and those two. That's not helping me. This is why this is a pain, because we got to go way back in the time machine to unit 2. What do you know about AB and DC? Look at my diagram. What do you know about AB and DC? They're you got me there. They're parallel. And they're also congruent. They're congruent, right? When I have a midpoint of DC, what's happening to DC? It is being cut in. And what's happening to AB? It is being cut in. What should you know about those halves? They should be congruent. What was that theorem? Halves of equal quantities are equal. Correct. Couple things before we finish the proof. You need to tell me what you're about to take half of are equal. What are we taking half of? AB and they got to be equal before I cut them in half. So is everyone all right if I just stick that in line 2? That they're equal. Because they're opposite sides, right? So I'm just going to stick that right here. AB and DC are congruent. Now tell me you're going to take half of each of them. I know this has been a while. I'm going to take half of AB. What do you think I should call that? Look at your diagram. If I take half of AB, should I call that AE or EB? Why AE? Why are you picking that one over EB? It's in the darn triangle, right? So half of AB equals AE. Half of, what's the other segment we're taking half of? DC. What do you want to call half of DC? FC, yeah, the one in the triangle. What in this proof said take half of it, or you're allowed to take half of it? Midpoint, darn right. Definition of midpoint. And then look what you're doing. You're taking halves of, what's AB and DE? Equal. So what can we say about AE and FC? They are congruent by halves of equal quantities. So this is actually just a 6th step instead. Halves of equal quantities are equal. And then why are the triangles congruent? What method you got for me? Method? Griff, finish us.
Side angle side.
Side angle side. They're congruent by side angle side. Be ready for halves of equal quantities tonight. 2 midpoints. 2 midpoints. Good work today. Trying to raise your game.